This is for Year 12 Specialists. It comes out of Chapter 8. It's 8A, question number 5D. And we're looking for this definite integral, and I need to sketch it first. Okay, so if I look at the graph of the inverse sine, it's going to have this particular shape to it. And normally there'd be -1 and 1, and it would go up to pi on 2 and negative pi on 2, but it's been doubled. So minus pi through to pi, and I'm looking for 0 to 1, so I'm looking for this area here. Now, I have no ability to take this definite integral because I don't have a rule for the integral of the inverse sine. But if I looked at finding this area here, I do know if that's A and this is B, I know that A plus B's area will be 1 times pi or pi, therefore B would be pi minus whatever A is. And A is going to equal the integral if I integrate with respect to y, if I know that that is y equals 2 inverse sine of x, looking at the inverse, x will equal the sine of y on 2. So the sine of y on 2 dy from 0 to pi. Because I'm integrating with respect to y, so from 0 to pi, the curve which is sine of y on 2. And that's going to be, the integral of sine will be negative cos of y on 2, but of course I needed a half there, so it's going to be a double on the outside from 0 to pi, and that's going to equal 2 times negative cos of pi on 2 plus cos of 0, which is 2 times negative plus 1, therefore 2. I'm looking at pi minus 2 square units for the area that I'm wanting.